Hello, welcome to the fourth problem of the Advent of Code 2022. Let's read the statement. As always, I haven't read it yet. We can start copying this input. So we can see there are some lists of intervals here. Let's save this. Maybe we can also copy the example. We usually want to run the example before. We're not aiming to go very fast, so it may be useful to first read the example. We check the example works, and then we work with the input. This is interesting. So here we see some intervals, 2, 4, 6, 8. These are the numbers inside these intervals. In how many assignment pairs does one range fully contain the other? Okay, that's interesting. So maybe we can go directly to solve this problem. What we can do is we can, for line in open 4.x, now we can split this in integers. So we could even let's say AB equals line.strip.split. We split by the dash, so we can take A1, A2 equals A.split. We can split from the comma. Maybe we can later have a regular expression or something to parse this in a better way. So let's say solution 1 equals 0, and here we can say if A1, let's see, is less or equal than B1. And so how can we check if this is completely inside? If A1 is equal and A1 is less or than B2 and A2 or B1 is inside A1, and let's have here a function def contains A1, B1, B2, B1, B2. So we can here return, and B2 is inside A2, sorry. So I think this is more or less, so A1 is less than this, so these both are after A1 and these both are before A2. So here we could do sol1, we could sum if contains A1, A2, B1, B2, or contains B1, B2, A1, A2, because we want to do sum either one. Print sol1. Let's see if this works. Python for, okay, too many values to unpack. What is the problem? Oh, we are splitting this in the opposite way. So first there's a comma, then there's the dash. Sorry. So, okay, so it's 2. That is what the example says here. It should be 2. So let's try to run with the input. 440, submit. Oh, it's not the right answer. Okay, maybe it's not less or equal. Fully contains. Okay, fully contains is fully contained by 4, 6. Two such pairs. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2, 8 fully contains 3, 7, and 6, 6 is fully contained in 4, 6. In pairs where one assignment fully contains the other, 1/11 is the pair. Let me make sure that these conditions are correct. So A1, both A1 and B2 are after 8A1, and both B1 and B2 are before A2. I think this is correct. So fully contained. Contains A1, A2, B1, B2, B2, B1, B2, A1, A2. Okay, and here it is 2, 4, 6, 8. I don't really understand what's wrong. It looks good to me. Larger numbers. Let's see the for.in. So these are the numbers. Let's print A1, A2, B1, B2 contains, or C. Let's do this for debugging purposes. Okay, so true. Yeah, this one is true. This one is contained in this one. This one is true, and this is not correct. This is not correct. So what is wrong here? A1 is less than these two. What is wrong here? 5 is less than 11, and 5 is less than 94, and 11 is less than 11, and 94 is less than 11, which is not true. And when we do the opposite, it should not work. So let me see what is wrong here. So print contains, I don't understand this. So 5, 11, 11, 94. Word sys.x. False. Okay, that is right. And if I turn this around, it is 11, 94, 5, 11. It's false. Okay, so what is wrong here? A1, A2, B1, B2. B1, B2, A1, A2. So this one is false and false, but then I get a true. I don't understand what's going on now. This one says true, but I still don't understand what's going on. This seemed like a very simple problem, but I'm having trouble debugging it. I thought I would get a quick solution, but no way. Okay, so here it is true, false. So 5, 11, 11, 94. 5, 11, print contains 5, 11. Oh my god. A1 is int A1, A2. Oh my god. I'm not converting this. So there's a simple way. Let's do this directly. Let's substitute all dashes for spaces. And let's substitute all commas for spaces. And now we can do a1, a2, b1, b2 equals map integer to line dot strip dot split. Okay, now 453. Gold star. Okay, we were comparing strings for whatever reason. This was working. I think, well, doesn't matter. We could add some type hints or something, but never mind. So this was an easy part, but it took us a long time. Okay. In how many assignment pairs do the ranges overlap? So what does this assignment pairs mean? Devs would like to know the number of pairs that overlap at all. In the above example, the first two pairs don't overlap. While they're meaning. So, okay, they have any kind of overlap, right? So, def overlap, a1, a2, b1, b2, return. So here we could say ranges equal. We are not going to to get a good names. So let's well, we could try to refactor this. Let's refactor this later. Okay, I changed my mind. Okay, so the part 2. In part 2, we want to do something very similar. Sol2, 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 overlap. So what does it mean to overlap? Overlap means that if b1, so when we overlap, we have A, B, C, D. I mean, there's a simple way of doing this that is absolutely inefficient, but we could say range A1, A2, set range intersection set range B1, B2. If we had done this before in this inefficient way, it would have worked because we would have gotten an error when trying to do the range. Okay, this is too low, so this is wrong. What are we doing wrong? Oh, because the range is +1, I think. So if we do this again, 919. Now I have to wait 45 seconds to submit. We can refactor this meanwhile, but so this solution, which is very inefficient because we compute these ranges and so on, would have given us the right solution, I guess, before. So while we wait, we could read the input. Ranges equals a list of what? Of this. Map for line in open for.in, right? Okay, so these are the ranges. So here we could do A1, B2, in ranges. I guess we can do that. And now we could also do sol1 equals sum contains. Now this is interesting. A range or contains the reversed range. That's not right. That's not right because it's not exactly the reverse what we want to do. Let's leave it here for now and submit this again. Okay, we got the gold star. Okay, so we had this problem of needing to convert to integers, which I forgot in the beginning, and that made us lose a lot of time. But now we can refactor this code. So, as always, I will change the print statements to these asserts. So 453 assert solution 2 equals 919. So this way we can do some refactoring. I will get an assertion error if there is a problem. Of course, we can replace this to here. Oh, this is, I don't know how I got the right solution, but this is wrong. Of course, I was making an OR. I was making an OR in the do we need this? I'm getting this error. I don't know what the issue is. Maybe it is this. Yeah, that's the error. So when we use map, this is the map is an iterator. So once we parse it, then when we parse it again, it doesn't work. So we need to convert it to a list. I'm not sure if I need to strip and split. I guess. Oh, sorry. Dot split. I need the split, but maybe not the strip. Okay, yeah, that's right. We could define a function, ints, that parsed all the integers. I know Peter Norvig from Google uses this function. It's very helpful to just get all the integers. We can maybe try to search this function later. Okay, so contains, it's either one contains the other or the opposite, right? So contains an overlap. Well, we will need to refactor this code because this is too inefficient. I want to make it more efficient, but then the contains, I like it. We could 1, 2, 1, 2. I think it makes sense to keep these names. We could say, I mean, does interval A1, A2 contain interval B1, B2? Turns check if interval A1, A2 contains interval B1, B2. Okay, and there's overlap. You could explain it also too. Check if there is any overlap between intervals A1, A2 and B1, B2. With this comment, we can explain what these functions are. So to do, make it faster. Okay, that's one thing we want to do. And then I like to make this a one-liner, right? We are just summing all of this. I would like to convert this to a sum. So one way we can do this is with a list comprehension, right? So this is either one contains the other or the opposite for this. And we close the sum. So this is a way of doing this as a one-liner. We need to do this to extract all of these numbers because we need to reverse the order when we do this contains, right? In the second part, it is much easier to do sol2 equals sum we could map. We could do overlap of the range for R in ranges. Let's see if this works. Yeah. So here we're using this tuple unpacking to extract this range and send it to the contains function. So in this way, this is an easier way to do this. We used one trick here, so well, later we will explain the lessons learned, and we could well, we could start now, but let's wait for later. So here, the only thing I have missing. So here we read the input. Then we have these functions. We could say this is part of part 1. And this is part of part 2. Sorry. Because it is. These are... We don't have any code reuse from part 1 and part 2 other than the reading of the input. So part 1, part 2... This function is optimal in my opinion. This, we need to do these 2 contains. That is fine. Of course, we could, if we follow the set, we could do this return. I mean, never mind. We could use this kind of set, but it doesn't make sense. Okay, so now to make this faster. So how do we check if there is any overlap, right? So there is, if I think it's easier to check that there is no overlap. Like, so there is, let's say, no overlap means that A1 is less than B1 and A2 is less than B1. Either both A1 and A2 are before B1, or, so this is, or A1 is larger than B2 and A2 is larger than B2. Return not no overlap. Okay, so this this works. So I think it's easier to think of it is easier to think of having an overlap in the negative way, right? So when there is no overlap, both A1 and A2 fall on one side of B1, or A1 and A2 fall on the right of B2. So we could have it here. If we wanted to do the opposite, it would be, well, this is some Boolean logic, right? But it would be that this or this are less or equal. This is an or, this is an and, but I think it's easier to think of this. So no overlap. We could also say disjoint. Is this the word? Disjoint. But we could anyway. We could return not this. We could return not this, but I think it's better to have the no overlap function variable. So I'm going to change it. No overlap. It's easier to reason about this. And then we return not no overlap. So here, let's expand this. This editor. So this is the final solution that I have come up with. So first we read the input. This is obvious. I modified the input to be only separated by spaces. That is useful. Then we have this contains function. Sum the booleans of whether this or this is true. One contains the other or the opposite. And then we sum whether there is an overlap. Okay. This is all I was going to say, but let's write down the lessons we learned. I think we lost a lot of time. I'm going to write it down because it's important. We lost some time for not converting numbers to ints. This is important because we could have said, I'm no expert on typing, but let's try to see So if we define a function that takes an integer, I guess we can define it like this. Let's return the square. So if we call it with like this, it would not work, right? So one way, I think this is the right. Now let me see. I don't know if you can say nm. N times m. Does this work? And what if I call it with, so if I call it to 3, obviously it works. But what if this is a 2? Does this work? Yeah, this works too. We need to put the type hint in every parameter, right? So I think the good thing, what we should have done is this. Int. Sorry. Int. So we could think of some ways. Let me add this as a string, so I don't have to add all these characters. So ways in which we could have prevented this, right? So one way is add type hints in the function parameters, right? And you do this with a function n is an integer, right? So here if we had added these hints, that would have worked. We could also have done something else, which is very typical, which is use asserts. So what is the problem with this overlap? Well, here where is our contains function, we are assuming that assert that a1 is less than or equal than a2, and that b1 is less than or equal than b2. So this is not obvious. Of course, if we run the code, it works, all these assertions work, but this is the kind of thing that we could do in the assertions that would make sure that this is working. So this is a use asserts. It's a typical use of asserts to check that the intervals in this case are ordered. So this is another way that we could have solved this problem of losing this time. Okay, what else did we learn? Well, we used one trick that we used, for this is specific for the advent of code, but we modified the input before parsing. So it's a trick that we can use to make our life easier. Not only in the advent of code, but maybe you need to read some tricky thing, and maybe it's just easy to first modify the input, make it more convenient to read. Then we used a small trick of sums of booleans. So we did a sum of true, false, true, etc. So this is a true is 1 and false is 0. So we want to count how many rows or how many items follow one condition. We can just sum these boolean values and we get the result. So that is useful. And here we just did this. Call a couple of functions. We use the sum function. There's nothing much else. And again, we used the tuple unpacking. So tuple unpacking to make a function call and list comprehension shorter, right? I mean, we could do the same thing here with a1, a2, b1, b2. This is the same as this, but using this operator, we can simplify this syntax. Okay. That's all for today. It was a simple problem. We lost a bunch of time because we didn't convert to strings, but this helped us think a bit harder on how we can improve that part. For us, the solution was to use type hinting, which of course we could apply also here, right? Let's do it. This is a very useful function that was added to Python. If I'm not wrong, I think it's PEP 484, but I could be wrong. And then we could also use these assertions that are the kind of thing that we could use in the real world. So when we implement a function that needs to be called in an intended way, but it is not explicit in the way that these parameters are or it is not enforced, let's say, sorry. It is not enforced from the language, then we can do this kind of thing. Well, this is the code we finish with. I hope you think it is clear enough. See you tomorrow.